Hi, everyone. Yes, as Tuesday said, hi, I'm Tobias, a contributor and developer advocate. And with us today is Aliash, a core compiler developer. Now, our agenda is very simple: make querying data better. And for that, we're going to introduce you to Prequel, a modern language for transforming data. But you might say, well, I already know SQL. Why do I need to find out about another language? So for that reason, we're going to start off with what is great about SQL. There's a lot we like about SQL, and we'll start with that. Then Aliash will take us through some things where we believe SQL could be improved. Then we'll look at introducing a pipelined relational query language, i.e. Prequel. And finally, we'll look at where today, right now, you can use Prequel and make your life easier in working with data. So be sure to stick around until then. All right, so what is great about SQL? And SQL is the lingua franca of data. I mean, it is spoken anywhere that you work with data. So from traditional relational database management systems to cloud data warehouses, and DataFrame libraries like Pandas and Polars have SQL interfaces, and also like data lakehouse engines like Apache Iceberg or Dremio, etc. So yeah. So, and what is it that we like about Prequel? Well, first of all, it is relational. It deals with tabular data where columns have specific types and the tables are related to each other. And there's a whole relational algebra that's well studied that works with that. And Aliash will say more about that. And second of all, it's declarative. So by that we mean that you declare what data you want to get out at the end, and the query optimizer, the query engine, has the freedom to optimize the query and decide how to get that data to you. So you don't have to specify which loops to write or etc. So that gives the optimizer a lot of freedom to come up with query plans that work better and make it efficient to retrieve the data. However, we think that's not the end of the story, and SQL is quite old at this stage, so we think there can be some improvements. So at this point, I'll hand over to Aliash to talk about what we think could be better about SQL.
Yeah, thank you. So the core thing that already was mentioned is the relational part. SQL was built a long time ago with even some Nobel Prizes. And the core thing here is that it uses relational algebra. This based on a well-defined mathematical constructs, relations. And here on the slide, you can see at the bottom some equations from that mathematical base of the relational algebra. You can see that we have tracks and albums, both of them relations, and you do a Cartesian product of them. And then you give this resulting relation to the pi function or sigma function, which is basically filtering, and you do filter over tracks album IDs and album IDs. And this is a basic join, from SQL. And then you pass that back up into the pi function, which is projection, and this takes only track ID, name, and title out of the whole relation. And on the top, you can see the corresponding query in SQL, and you can see that it's matching a lot, but it's the same thing semantically, but not syntactically. And you probably know that if you search the internet for formal definitions of SQL, you will find relational algebra, because most papers just define the relational algebra as the semantics of SQL and then slap over, okay, and this can be done with where keyword, this can be done with from keyword. But you never have defined the name resolution rules and stuff like this. So there's a disparity between actual relational algebra and SQL. But we actually equate these things in a lot of ways, to the point where we named the move from non-relational to non-relational databases NoSQL. Yeah, so how did we come to here? it's an old story. SQL was evolved from structured query language, which looked like COBOL and still does. And this is a good indication that this is an old language. But it's also visible in some other constructs. Like here on the top, you can see a query for window functions that has basic syntax of an aggregation function, sum total. But then slapped over that is a keyword over that now signifies that this is a windowing function. It does not do aggregation. And yeah, it may be the best looking way to represent this in a sentence, but this is not really nice design of the APIs. We can do much better than that. Also, the distinct keyword, for example, is a very important keyword that, if you know a little bit about SQL, is applied at the end of your query. But because we people speak the way we do, it is inserted in the front of in SQL syntax. So there is some disparity of semantics and syntax here. And then SQL is not really composable. It does not feel like a programming language. And with this, I mean, look at this query here. I have query from tracks, and I'm grouping by album ID. And then I want to do join by this album ID that I just grouped by. And this is not possible to do with just one query. I have to nest queries here. And I could be using common table expressions here, but this is not really, it's not easy to do. I mean, you have to move things around. The flow is not from top to bottom. And I don't feel like this is composable, and I feel like we can do better. And now a little bit more about name resolution. SQL, here I have a query that starts from albums, and it defines a new name for the name column, new alias named album name. And this album name is now available to use in group by and order by, but not in where. Because if you know SQL, you know that where happens before the projection. So the alias is not available in where. And how do I know that? Well, you have to memorize it. For each clause, there are their own name resolution rules. And order by can even contain just number literals that refer to positional column in your relation. And this is, I mean, it's documented somewhere, but this is not consistent across databases. And this is the last problem we have with SQL. We used to work on just one database in your day job, but it's within the days of data science and interacting with multiple data warehouses, you have to know a few dialects just for your day job. And you know that queries are not just, does not just work if you move them from one database to another. Like here I have example for a simple thing like specifying the limit of your query. And you can see that Postgres syntax is not the same as Microsoft SQL. So you basically have to keep track of all this. And this is not a good approach, and we think that we can do better. And the main question now is, how do we fix that? It's a tough question. And at Prequel, we just said, well, you don't fix it. Let's start anew. Let's build a new language and keep the good parts of SQL. And with this, I mean mainly relations, relational algebra that is well-defined and works. And we built this with consistent semantics. Define what's the exact name resolution and use that name resolution across all your clauses. Design a syntax with new features that we acquired over the last 40 years of language development. And if you want to be really the cherry on the top is that you want to compile this language to SQL, so it can execute on any database that supports SQL, which is basically any relational database. Okay, so we named the thing Prequel, which stands for Pipelined Relational Query Language. I already talked about relations, and query language is self-explanatory, but let's focus on pipeline here. Because in Prequel, we don't have queries. The base unit here is pipeline. And this is basically a series of functions that transform your relations. Here on the left side, you can see that I start with from tracks and then select a few columns: title, unit price, and album ID. This here is a list because the whole list of columns is just one argument. Then I derive a new column, gross price, which is unit price times some factor, and then filter the rows by this just defined column, gross price. Then I do grouping, and don't mind the whole syntax here. This is aggregation by album ID. We have this defined in depth, but I don't have enough time here. And then I do filtering again. And if you know SQL, the first filter would translate to where, and the second one would translate to having, because I'm filtering on number of tracks, which was just aggregated. And then I apply some sorting and take 10 elements. And the first thing you can see is that the flow is top to bottom. It's always happening one step at a time. And actually to the point where you could actually cut the pipeline at any point, and the first part would be a valid relation. So you can think of, okay, I have my pipeline, it returns a relation, it has this and this columns, and then just apply a new function on that. And you can just keep going and applying new functions and transforming your relation. And this is really nice to debug because it's easy to just pull some some prefix of the pipeline out and do something on that, or define it in a variable and so on. Okay, so to get deeper into benefits of this approach is that I have to tell you that we don't have clauses, if you paid attention. No clauses, but functions. Each of these keywords that you see on the screen, these are functions that take arguments. And this is important because we designed them to be orthogonal to each other. With this, I mean that they don't share much functionality between each other, and they try to be as different as possible. And this allows us to define basically 9 different functions that transform your relations. And this is all that you need to learn to basically get started with Prequel. It also makes them really composable. So we can do things like inferring that, oh, hey, filter and sort don't interact with each other, so you can switch their place as you wanted to. And now to go a step further, we strive to be a functional language. So obviously we apply functions, but here I'm actually defining a user function. Let's read it together. So function take cheapest takes a number and a relation, and then defines a new pipeline that takes that relation, applies some sorting over unit price, and then takes n elements. And this is now a function like any other function that we used in the pipeline before, and we can use it as from tracks, take cheapest 10. And now you probably get the feeling that this is becoming composable. This feels like a programming language. Well, at least I do. And on top of that, we can now put aliases in front, which is way more readable than having them in the back. Have a separate syntax for dates, for date literals, like we are a database, which we should have that. The F strings for like in Python for basic concatenation. We have coalesce operator for nullability checks. It's easy to comment out lines because lines are usually just one transform per line. So this is way more easier. And we have trailing commas. We have underscores in numbers to make them more readable. Just the nitpicks that we acquired over the last 40 years of language development. Okay, and also one thing that we have in our principles is that as a developer, when you're querying databases, you are thinking about your data, you're writing this down, and then executing your query and waiting for the result. And you know that if you want to be productive, to be fast, you shouldn't be waiting for a database. If you have to wait 5 seconds, a minute, 10 minutes for CI or something, this blows your productivity away. And you want this cycle to be fast. And that's why we never try to connect. We infer from your queries. So when you're building a pipeline and you say, from this table, select these 2 columns, the compiler remembers, oh, there are these two columns in your table. And it does not try to connect and infer and try to introspect your database, but we are planning to add support so your language server could pull in the definitions to your actual file to even help you even more. And this allows us to fail early and give you information like, hey, you missed a comma here, or hey, the relation here does not contain this column. You did something wrong. And this really helps your productivity, and also the fact that we can provide good errors. Here on the slide, I have an example of actual error from the compiler that's saying, okay, you specified column name before the list, but it should go inside the list. And this is something that modern languages can do, and it really helps your development. Okay, so that's all I have to say about Prequel. Come and check it out. And Tobias, you tell us how.
Yeah. Okay, thank you, Eliash. So yeah, I mean, I hope there's some things you've seen that you like there, like you ask yourself, how can I bring those ergonomics and that composability to my workflow? And yeah, luckily you can get started right now. So if you open up a new browser tab and you go to prequel-lang.com/playground, we've got our Prequel playground where we've got the compiler R2WASM running right in your browser, and on the left hand side you can enter your example Prequel queries, and on every keystroke they'll be compiled, and if it's a valid query, it will produce SQL on the right hand side. So you can try it out right here, right now. For other work in your day-to-day job, next we've got Prequel Query, PQ for short, which a tool like JQ for working with JSON is a Prequel tool for working with relational tabular data in the command line right in your terminal. And the example query there shows you how you can run a simple Prequel query over a CSV file. You can also use query multiple CSV files or Parquet files, join them together and run any kind of query on those. So, and that's all made possible by the power of DuckDB and Data Fusion, and you can switch between those backends. And that's something I've used in my day job, and I really enjoy it. Next, we have our VS Code extension, and the screenshot is already a bit out of date because this has seen a tremendous amount of work in the last few weeks, and it integrates very nicely with other SQL tools, extensions, and similar to the playground, you can write your Prequel query, preview the SQL, and then execute it right against your database backend from within VS Code. So be sure to check that out after that talk. Next, Python, which is another universal well-loved language in data science. And there it's as simple as pip install PyPrequel, and then that gives you access to a Prequel accessor function on Pandas data frames. And you can just run Prequel queries right on your Pandas data frames. And second of all, we also have a Jupyter magic, which is the bottom half of the screen. And there with a %% Prequel magic, you can write your Prequel query right in the Jupyter cell and then execute that either against data frames in memory or other database backends that you've got access to. Finally, we also have R, and there's a Prequel R package that we can that plugs right into the tidyverse, and you can run your Prequel queries in R. And just if you look at the bottom example, using the tidy query show dplyr command, you can even generate dplyr queries back from Prequel. And if you just compare the two, you'll see how similar Prequel is to dplyr, and because dplyr was one of the inspirations for Prequel. That is just a taste of some of the extensions, and there's also JavaScript ones like Node, and you've seen a lot of recent work on JDBC, so you can even use Prequel in tools like dbeaver or DataGrip to interact with your databases. So there's a lot happening. Go and check it out, prequel-lang.org, or on our GitHub at prequel/prequel, or come talk to us on Discord. We are a very friendly, open community. PRs are very welcome and get merged quickly. And yeah, with as a community, the language will grow from strength to strength. So come check it out. And thank you. That's all from us.